Dear students, this is my third class. You are aware. ഒരു കാര്യം പറയാനുള്ളതെന്ന് പറഞ്ഞാൽ നമ്മുടെ പരീക്ഷ പെട്ടെന്നുണ്ടാവുമെന്നാണ് പറയുന്നത്. ബട്ട് ഒരു മാസം കൊണ്ടൊന്നും ഈ 2 ചാപ്റ്റർ തീർത്ത് തരിക എന്നുള്ളത് വളരെ ബുദ്ധിമുട്ടായിരിക്കും. ഈവൻ സ്റ്റുഡൻസ് പോയിൻ്റ് ഓഫ് വ്യൂവിൽ വളരെ ബുദ്ധിമുട്ടായിരിക്കും. ബട്ട് ഒരു കാര്യം പറയാനുള്ളത് എന്ന് പറഞ്ഞാൽ നിങ്ങൾ ഇതിൻ്റെ കൂടെ തന്നെ കുറച്ച് സമയം കണ്ടെത്തിയിട്ട് വർക്ക് ചെയ്യണം. ഞാൻ ഈ സാറ്റർഡേ സൺഡേയിലേക്ക് ഒരു വലിയ വർക്ക് തരാൻ വേണ്ടി പറയാണ്. ചുരുങ്ങിയ ഒരു 25 മോളിക്യൂളിൻ്റെതെങ്കിലും നിങ്ങൾ ഐ വിൽ ഗിവ് ദി എക്സാമ്പിൾസ്. അതിൻ്റെ എല്ലാ സിമെട്രി എലമെൻറ്റ് കണ്ടെത്തുന്ന രീതിയിലേക്ക് നിങ്ങൾ വരണം. ഓക്കെ, അത് ഡ്രോ ചെയ്യുന്നു. ഞാൻ അസൈൻമെൻറ്റ് തന്ന എല്ലാവരും അതിൻ്റെ സിമെട്രി എലമെൻറ്റ് ഏതാണെന്നുള്ള കൃത്യമായിട്ട് അസൈൻമെൻറ്റിൽ ചെയ്തിട്ടില്ല. പക്ഷെ അത് പോരാ, ഓരോ സിമെട്രി ഓപ്പറേഷൻ്റെ ഇതും ഡ്രോയിങ് വേണം. ഓക്കെ, ഫോർ എക്സാമ്പിൾ let us take first example NH3. Okay, so NH3 molecules. So NH3 molecules, you know that this is the NH3, right? Okay, so what are the symmetry element present in the NH3 molecules? So I am just denoting H1, H2, H3 for this sake. Okay, so here you know that I have shown in the last class it has the C3 axis, right? C3 axis. So first of all, you want to write down the order of the each and every molecule. Okay, what is the order of a point group? The order of the point group is the number of symmetry element, total number of symmetry element present in a group is called order of the group. Okay, so what happen when you do rotation, say C3? Okay, C3. So I'm just showing. Thing is that how you do the first operation is very important. So suppose you are doing the rotation about this axis, that is like this. Okay, rotation like this, the clockwise rotation. Okay, so what is the C3? What happened on doing C3 on this molecule H1? So you write like this. There will be, so first thing you have to do the same appearance for this is the, so then only it is symmetry operation, right? You have to write if it is a symmetry operation, it seems to be same. That is if you I'm writing this bond and this bond, this bond and this bond, this bond. So if I'm writing the like this and this is not a symmetry operation, right? I mean, if you are not writing exactly, the position of the hydrogen is not exactly same as your initial structure, then it is not a symmetry operation. You have to care. So then what happened to the hydrogens? So this H3 will go. What will happen on rotation about the C3 means how many degree? It is 120 degree. Okay, 120 degree rotation. What will happen? H3 will go here and H1 will come here, like H3 will be here or H1 will be here. H1 will be here, right, on rotation, and the H2 will be here and H3 will be here. Okay, this is C3. Now this is a different orientation, right? This is a different orientation. Next is C3 square. Okay, C3 square. That is what happened. You are doing again C3, same rotation, same type of rotation. That is if you are doing C3 square, so what will happen? C3 square, the again, that is again you write the exactly these are very important in the symmetry operation. Okay, you have to write down the same structure, similar structure of this. So C3 square means the H1 will go here, H2 will come here, H3. So H1 will be in the place of H2, that is H1 here, and H2 will be here, and H3 will be here. Okay, these three are different, that is in this position it is H3 here, here H2 is here, it is H1. Again you do rotation, that is C3 cube. Okay, C3 cube. C3 cube. Okay, C3 cube means what? It is C3 cube means the H1 will go here, H2 will come here, H3 will come. That is, this is the C3 square. That is, it is identity operation. Okay, you remember, the identity operation means some operation is done. Okay, same appearance means you have, after doing some operation, that is, it is rotated. One more thing, let me tell you one more thing. That is C3 cube means you can divide by 1, that is 3, it is 1, that is it is a C1. Okay, so it is identity operation. So C3 cube is identity operation. Okay, this is clear. Now how many okay, rotation, whether C2 is there, C1 is there, C3 is there. Okay, C2 is not there, no other rotation axis. Now let us see the what are the sigma. Okay, so now you have to also identify the principal axis of rotation. So what is this principal? It is C3 itself. There is no other C2 is not there, so it is a principal axis C3. Now what are the sigma, that is sigma. So first thing, there is no this is not a planar molecule. This is not a planar molecule. So what will happen? Now you have sigma, the plane, that is sigma v's. You just sigma v's are there. So sigma v's means I told you in the last class, sigma v means the plane which is passing through the principal axis. Okay, so sigma v. How many sigma v's are there? 3 sigma v's are there. That is sigma v. So you have to draw in your notebook all sigma v's. Okay, I have seen many of your assignment. What you have done, you just done this sigma v is there, sigma 2 is there, like that. But I need your correct representation. For example, I am taking the sigma v which is passing through sigma v1. So I am just taking sigma v, sigma 1, sigma 2, sigma 3. Okay, which is sigma 1 means the plane which passes through the plane which passes through the H1. Okay, sigma 2 is plane which is passes through the H2, and sigma 3 is plane which is passes through the H3, and of course along the nitrogen. Okay, so let us see what happened. Okay, so when it is passes through H1, that is, you have to draw your sigma v's also. This is the sigma v. Okay, how beautifully you draw means it is up to you. Okay, that is it is like this. Okay, so what happened on sigma v1? So what changes will take place in the position of the hydrogen, all the hydrogen H1, H2 and H3? That is our interest. Okay, so this is your reflection plane. What happened? The H1 is unchanged. Okay, so sigma H1, so H1 is unchanged. That is nitrogen and hydrogen. Again you have to look at the same structure, it should be same structure. Okay, H1 is there itself. Then what will happen to H2 and H3? When you reflect, what will happen? Its image will be here and its image will be here. That is okay, H3 will come here and H2 will go here, right? So this is what happened on sigma V1. Similarly, what happened and sigma 2? On sigma 2, that is what will happen? Again, you don't start from here. Okay, so if you are doing sigma 2, that is not from here. That is, if you are doing sigma 2 from here, what is that? Okay, I will tell you, you just keep it there in my mind. I am just coming, that is our next topic. Okay, so when sigma 2 is, so your initial, again you have to keep your initial molecular the orientation. Okay, so on sigma 2, so this is your Hn and H2, it is as it is. Now what will happen? H1 and H3 position is changed. Okay, so this is H3 and this is H1. Okay, you got. Now suppose you are doing sigma 3. Okay, so this is, so remember your initial position is very important. So suppose your initial position, you are writing H1 here, H3 here, H1 here, H2 here, but there is no, that will not affect your if your further symmetry operation. But once you initially put your position of the hydrogen, you have to keep that in your clearly in your mind. Okay, you don't next when you do next operation, though you don't change that position. Okay, so what happened to sigma 3? So I am just writing here, and H3 here. Okay, and the H2 and H1. This is your H1 position, and this is your H3 position. Okay, so this is sigma 3. This is sigma 3, this is sigma 2, this is sigma 1. It's clear? Okay. So for NH3, so what are the symmetry, what are the order of this group? You see here, that is C3, then C3 square is there, C3 square is there, C3 square, then C3 cube, that is I can write E. Okay, you can start other E starting. Okay, now sigma 1, sigma 2 and sigma 3. Whether any other symmetry elements are there? No, inversion is not there, C2 is not there. So this is your complete all symmetry element. That is the set of all symmetry element. Okay, so mathematically it's a set of all symmetry elements. So number of symmetry element of a particular molecule is the order of the group. So what is the then order of the order of this group? So tell me, what is the point group of this? So it is C3V, right? C3V. So what is the condition for CNV? If there are CN and NCV, then they are called CNV point group. So it is 3C3V point group. So order is 1, 2, 3, 4, 5, 6. Order is represented small letter h. So that is 1, 2, 3, 4, 5, 6. 6 is the order of the group. Okay, I think it is clear to you. one more, I am giving you a sheet, so you have to go through it. If you are interested and very much serious, there are about 54 examples that is uploaded in your classroom. Okay, so you have time, you have 2 days time. I am not saying that all 64, but you have to look at all 64 and you identify. It's very interesting. I will in the next small video will be there to flowchart, but you don't need any flowchart to identify the symmetry of a molecule. If you are practicing this, you automatically I have given you definition of all the point group definition, and you look at the point group and you identify. For example, let me take water you do yourself. Okay, let me acetylene. Okay, I have this is I have. Okay, this is very simple to identify. So it is a linear. Okay, so all linear molecules, you know that any degree of rotation, any infinite degree of rotation along this axis is a symmetry operation. Okay, so that is, I told you, it is C infinite. Okay, that is let us see. So you can say that C infinite is there. Okay, and what they have C2 axis is there. Here you see, you can also have infinite C2 axis, because this is both direction. So they also has a infinite C2s, that is, you rotate with any degree rotation, the perpendicular to, that is alpha. Infinite C2 is also there. So if one group has the Cn and the n C2s, that is automatically become D point group, that is Dn, that is D alpha is D alpha. Okay, now it is a, you know, that linear molecule, and it is they are the planar molecule. I mean, they can be put into a plane. So that is it is also has the sigma h. So okay, alpha, again I can tell you that in C infinity is there, infinite sigma v is also there. So infinite sigma v is also there. Okay, so infinite, if C infinite and infinite Cv, then it is belongs to C infinite V. Okay, for example, carbon monoxide, there is no C2 axis here, but there are C infinite and infinite Cv. So this belongs to C infinite V point group. Okay, so but here, and infinite V is also there, and also sigma h is there. There is no sigma h. Okay, sigma h is there. So it is also sigma h. So that you can say that this belongs to D infinite h. So this is the point group of this. Okay, so what is the order? It is infinite. Okay, infinite number of order of this group, infinite. Okay, infinite number of symmetry elements are there. Okay, can say that I is also there. Normally I is also there. So you look at the chart I have provided to you. Okay, so I'm taking few of example only. Okay, remaining you go through that, and I am expecting you draw all, or at least for your rough work, that will be beneficial for you in the examination and the net examination, etc. It is very important topic, okay, in the next examination. I'm taking another example, that is I'm taking one, this is not a complicated, okay. So what is this? Naphthalene. So of course it has sigma H, okay. So let me tell you, normally I can tell you that if a molecule has the sigma H, they also has the I is also there, okay, don't forget. So you can topple it. A molecule can be toppled, or inversion. So they also has I, okay. So that's shortcut. And then what? C2 is there. How many C2s are there? How many C2s are there? Okay, how many C2s are there? So you can say that C2, this along the along this one C2, okay, this axis, say x-axis, say C2. Now along this direction, say I'm saying, so this is Z, right, C2, and this is X. So another C2 is there, okay, and another C2 along the Y, okay, that is C2. That is, it has C2 and 2C2. What is that? Cn and NC2. That is D. Okay, okay, D. Okay, D. D. D2. Okay, D2. It is a planar. Okay, it is a planar. So D2H. Okay, like that itself you can identify the, so D2H. Okay. Similarly, let us, I forget to take a very common example, that is BF3. BF3. So it has C3 along the Z, C3. Then okay, C3 is there. Okay, I can take C3 square. Then C3 cube, that is E. Okay, no problem. Okay, so then C2 is there. How many C2s are there? So C2. Okay, so how many C2? 1, 2, 3. 3 C2s. Okay, so it just look, Cn and N C2s, that is C3 and 3 C2s, that is belongs to D3. Okay, okay, sigma V is there, sigma H is there. Okay, sigma H is there, so it is D3H. Okay, like that. So and you can say that it also has I is there, okay, I is there, 3 sigma V's, okay, 3 sigma V's, okay, 3 sigma V, that is 1, 2, 3, okay, 3 sigma V, okay, then S3, okay, so S3 is there, S3 raised to 5. So suppose you may have some doubt. S3 is denoted but why the S3 square is not? So this is a question is come quite to me, but there is an answer for this also. Okay, okay, let us is it possible to identify or how you can do this operation? Let me give you this question as it is for you. If you have any, if you are not able to find out why the S3 is there, then S3 square is there, S3 cube is there, okay, S3 4 is there, S3 5 is there, S3 6 is there. Why? I told you, if a molecule has S3 or n, this is an odd number, the S3's cube is not E. Okay, S3 raised to 2n, that is Sn raised to 2n is E, that is Sn raised to 6 is E. Okay, so from itself I think you got some clue why S6 S3 raised to 6 is E. So E is there, right? So like that. Okay, so that is why C2 square is E. Why neglecting all repetition? That is your order. That is 1 2 3 4 5 6 7 8 9. That is 1 2 3 6 3 3 6 6 7 7 3 10 11 12. So order is 12. Okay, so order is 12. So order is 12. Okay, order is 12. So like that. So whether I need to do few more examples, or let me go for next topic. I think I am stopping here this discussion. I hope every one of you will do the exercise what I have told you, and in the next class I will, that is in the Monday, you have 1 more hour. In there I will give the shortcut, that is not shortcut. For me that is not shortcut. So if you feel that it is shortcut, you can do that. That is also, that is flowchart to identify the symmetry operations, symmetry, I mean point group. So here the symbol very short. You have CNV, CNH, okay, CNH, then DN, DNH, DND. So one difference. Let me show you what is DNH and DND. Yes, I think that is good. You know that ferrocene. Okay, ferrocene. They have two type of ferrocenes are there: staggered ferrocene and eclipsed ferrocene. Okay, ferrocene. What is the structure of ferrocene? This is a staggered ferrocene. Okay, staggered ferrocene. Okay, I don't know, is it there in your example? Okay, staggered ferrocene. That is staggered ferrocene. Sorry, eclipsed ferrocene. Sorry, this is eclipsed ferrocene. Okay, in this eclipsed ferrocene, what are the C1. So in the ferrocene molecules. You see here, C1 is there. Okay, this is there are C5, right? C5 is there, C5 along this direction, C5, C5 square, C5 cube, C5 raised to 4, C5, that is E. That is, how many C2s are there? You can say that you rotate along this, that is, you can, if it is possible, you also define how the axis is going on. Okay, when you are doing your examples, I told you that you do at least 25 out of you take randomly out of 64 examples, you take randomly and you draw the 25 molecules, its symmetry elements, symmetry operations. It is a very big task, but anyhow I hope you will do, every one of you will do. This is very interesting topic, because to understand the molecular symmetry and this operation, it is very essential, because I told you I have no enough time for do all examples because of this situation. Okay, now there are C2s which is passes through this this direction, that is do the 5 along the one this angle, that is the middle, and you can say that along the sigma v, and which cut this is not cutting actually, but this passes through the iron. Okay, and along this direction you can say that along, but this sigma v plane. Okay, so there are 5 such axes. Okay, 5 such axes. So you can say that 5 sigma 2s. Okay, 5 sigma 2. So then automatically what will be the one, let me tell you one shortcut. Don't it is good to look at the I and S. Okay, you can identify the point group. You don't need to whether S is, if S is there, you can to find out the order of the point group, you need to you also need S. But to find out the point group, you don't need to know about the S and I. Okay, so that's a shortcut. So 5 C2s are there, so it belongs to D5. Now sigma h is there or not? You can say that it has an horizontal plane, because these two are staggered, and that is, it seems to be a mirror the mirror plane to each other. So it is there, it is sigma dh. But in the case of ferrocene, in the eclipsed form, so what is the ferrocene in the eclipsed form means? Sorry, this is eclipsed, staggered form. That is, its structure is like this. I don't know, I have drawn in different shape, right? Okay, this is the ferrocene, that is the staggered form of the ferrocene, another conformation. So here you can say that C2 is there, 5 C1 is there, okay, C5 is there, C5 is there. Okay, so when you rotate along this C5 means what is the degree, you find out if you want, 360 divided by 5, that is whatever the degree. Okay, this degree rotation, it will come. It's like that. There are C5 and C2 is also there. C2 is also there. C2 is also there. Okay, C2 is also there. That is 5 C2 is there. Okay, 5 C2 is there. Okay, 5 C2 is there. So when you rotate like this along this along this for look at this molecule. So you rotate like this, it is a symmetry operation. So it is sigma, that is C5 is there, 5 C2s are there, so it automatically come. So TD and OH, they have the octahedral geometry or tetrahedral geometry, don't worry, and IH, it's octahedral geometry. If it is like that, only you look at that symmetry. But here 5 C2s are there, okay, so it automatically DN, and sigma H is not there because this is not exactly mirror plane to each other, okay, but it has sigma D, okay, it has the sigma D, okay, sigma D's, that is sigma D's are there. So along this plane, that is so it has sigma, that is 5D, okay, 5D. This is the symmetry point group of the ferrocene in the staggered conformation, okay, like that, okay. So similarly, you look at you go through these examples, and if you find any kind of difficulty, you can ask me directly by personal chat, okay. I'm continuing the next topic, okay.